Christian Holler is a German champion in which competitive sport? A. Counter-Strike, B. Chess, or C. Lockpicking? Now you have 10 seconds to think about it and write it in the chat. And then Christian can solve the riddle by introducing himself.
There's a lot of guesses already, I see.
Welcome, Christian.
Well, thank you very much, Paul. So yeah, I guess the 10 seconds is over. I cannot see the chat. I would have loved to see how many people say Counter-Strike or something like that, but actually it's lockpicking. So yeah, it's a very interesting hobby. Very addictive hobby. I can very much recommend that. But yeah, today I'm here to talk about fuzzing, of course, and this is a quite an opportunity for me here. I'm giving my first talk that is non-technical. I used to give a lot of technical talks, and we have many great technical talks at this conference already. But I figured that now where fuzzing is getting more and more popular and more companies are actually trying to deploy fuzzing, it's important to talk about the human component when deploying fuzzing. There are many problems that we can hit in this area. So a little background about me. I work at Mozilla. I work on the Firefox browser. I've been working on that for 9 years, primarily fuzzing. Browsers have adopted fuzzing at a very early stage, also in very specialized ways. So my primary responsibility about fuzzing is fuzzing JavaScript engines, grammar-based fuzzing, but I've also started fuzzing other areas of the browser. And Firefox is actually a pretty large project. We have around 16 million lines of source code. And I just gathered the statistics from GitHub. Last month, we had 340 authors with roughly 2,500 commits. So it's not just a large code base, but it's also a very active code base. And yeah, Firefox has a lot of components, a lot of functionality, just like every browser, that needs security testing, Q&A, and fuzzing in particular. Usually, there are a lot more features in a browser than people are aware of. And of course, behind each of these features, there is one or more developer teams that have domain knowledge about this particular area. And domain knowledge, in my opinion, is one of the most important parts in fuzzing, because the developers, they usually know how the code is architectured, what are the contracts between the different components that you have. And they also usually know something about expected behavior, in particular in edge cases. Sometimes this is not obvious how software should behave in certain edge cases, but the developers will know. And most of the time, developers also know something about weaknesses of their code. They sometimes know stuff about what's happening in the wild where they cannot make sense. Things like that can be very helpful to know when starting fuzzing. So overall, I think it's pretty clear by now that this lone warrior approach of fuzzing is not sustainable. You might actually be able to get some fuzzing up and running. You might even be able to find some bugs. But if you want to have continuous, sustainable, high-efficient fuzzing operations, it's not going to work like in solitary. So instead, what we need is a mutual trust relationship between the developers and the people who deploy fuzzing. Of course, this kind of relationship is required for other things as well, especially for security, for Q&A. But I believe in fuzzing in particular, we have some properties that amplify some of the problems that can hurt this relationship. And fuzzing in particular depends very much on this relationship to work. So this talk is going to be mostly about the do's and don'ts that help or hurt this particular relationship. And I'm going to start out with a big don't, or a situation that shows some anti-patterns, and I call this the ninja style of fuzzing deployment. And this might seem extreme as an extreme example now, but actually I've seen this even happening in reality, especially security. And this ninja style essentially means like you build your fuzzer alone and in secret, and then you rapid fire bugs at the developers, and you'll feel somewhat superior when you've done that, when you've heard that piece of software. And this is of course, to some extent, this is also a normal human reaction, but it's of course totally not helpful, because what you will get when doing this is defensive behavior from developers. And there's multiple reasons why defensive behavior pops up in fuzzing from the developer side. I'm trying to summarize just the major cases here. The first thing is that developers can quickly feel overwhelmed. Fuzzing is something that can produce a lot of bugs in a very short time, and that can feel very overwhelming. In particular, if there is a lack of resources already in the developer team, adding another test method on top of it is going to cause defensive behavior for sure. But then there's also code ownership bias. And that's something not to underestimate. Like if you develop a particular piece of code and you have a certain emotional attachment to it, usually you do not like other people finding bugs in there. And though that is not a very logical reaction, it's a very human reaction, and we need to keep that in mind. So here's an example that I got from Marcel, actually. It's a very nice example. There was some person that wrote a Z3 fuzzer, and they started filing bugs in GitHub. And at some point, one of the developers said this: please stop filing fuzz bugs for the next few weeks until they can be addressed. So this was a very polite comment, but clearly they felt like overwhelmed. Just because of the sheer amount of bugs, amount of open GitHub issues, that didn't look good to them, and that probably felt really bad for them. So that's something you should try to avoid. So start with summarize some of the don'ts here. Do not surprise your developers. It's a really bad idea to do that. Also, do not act superior or adversarial in any way. I know this is kind of common in the security industry to act as an adversarial, but you should not act like that towards developers. It will hurt your relationship, of course. And last here is do not assume equal priorities. Like the priorities of the developer and your priorities are different. Of course, you share a common goal, but developers have different priorities, and you have to respect that. So instead, what you should do is you should start with a kickoff meeting. And in my opinion, a kickoff meeting should include developers, fuzzing, and management. That means management from both sides, because each of the parties needs to feel backed up by management and not feel alone in that meeting. Also, if you have previous success stories of deploying fuzzing in your company or somewhere else, show it. Like show it how you helped some other developers to solve certain problems, how it made their lives better, because that will make feel developers better about this meeting. Also, very simple advice that, in my opinion, helps quite a bit. Offer your help, like ask for problems. Ask developers, like, do you have any problems with your code? Maybe you can help. And maybe you can help. Maybe you cannot help, because fuzzing is not a universal problem-solving solution. So, but no matter if you can help or not help, at least you offered your help. You showed genuine interest to help the developer, and that's going to be appreciated. And of course, in that meeting, you should define goals, where you want to get with fuzzing. Also define where you might not want to get, because not everything can be done with fuzzing. And if necessary, allocate specific resources on the developer side to actually deal with the results. This can be very helpful, especially if there's resource constraints and developers might feel like they cannot actually spend the necessary time on fuzzing. It should be very clearly defined that they can, and feel backed up by management on that. And of course, you need to educate on the requirements of your particular fuzzing method. So when you start fuzzing, you usually pick out a certain method, how you want to test a certain piece of software. And each fuzzing method has its own requirements. And developers need to be aware of these requirements and not be surprised later on by additional requirements or changes that have to be made in software. So these two here, the previous success stories and offering a help, those are primarily here to avoid defensive behavior in that particular meeting, while these later two, they can actually help you to avoid conflicts later on during deployment or during operations. And when we talk about requirements and goals, as I mentioned earlier, usually there is an overlap between what developers want and what fuzzing wants or needs. And of course, you have this common goal. You want to make the software better, but there is always some things that the developer wants or expects that fuzzing cannot give you, this orange part here. And I guess we all know this, like when you have a hammer, everything looks like a nail. And in fuzzing, this is also very common. If developers get enthusiastic about fuzzing, they might expect things from fuzzing that fuzzing cannot deliver. And you should make it very clear what to expect and what to not expect, because you don't want to disappoint anyone later on. But also very important on the other side to get right is the requirements that fuzzing has that are not on the developer's agenda initially. And I want to give a very simple example for that. It's probably one of the most simple example requirements that you can have, and that is that bugs must be fixed. If you have an accumulating amount of fuzzing bugs that are not being addressed by developers, then this will hurt fuzzing operations. And I believe everyone who has ever tried to deploy fuzzing anywhere has heard about this before. Like a developer saying that a particular bug is not interesting, so please ignore it. And we need to educate developers why this doesn't work very well for many methods of fuzzing. But even if you did, and you've convinced the developer that all of the bugs must be fixed, you might get something like this. It's them saying that it's not a bug and rejecting your work. And this is actually a situation where defensive behavior on the fuzzing engineer side might come into play, because if your work is being rejected, you're not going to feel very good about that either. So you need to be aware of that as well. And in my opinion, this can be solved by having a contract about what constitutes a bug. And of course, this contract will not be static. It will change over time with the software. But you should have an initial good idea about this contract. And I'm going to give you a very simple example from fuzzing at Mozilla, in particular from my area, which is the JavaScript engine. So we have this JavaScript shell that we use for testing JavaScript. And it's a simple shell. You can start it up and you can run some JavaScript in there. And this is as technical as the talk will get. And there's some extra helping functions in that shell. There's one function in particular that's called crash. And if you call that crash function, the shell will crash. And this is, of course, not a bug. This is a feature that can be used to test certain tools. And if the fuzzer now starts running on this shell and you're hitting crash over and over again, this might actually hurt fuzzing. So instead, we can start the JavaScript shell with a fuzzing safe flag. And if I now try to call crash, I get an error. Crash is not defined. That's because the JavaScript developers decided to remove the crash function when the fuzzing safe flag is set, and a lot of other functions that are not safe for fuzzing. But the point here is, if this crash function was still defined while the fuzzing safe flag is set and it crashed, this would be considered a bug by the developers and they would commit fixing this bug. No discussion. And that makes work with the developers here very easy. We have this contract essentially that says anything that crashes or asserts under the fuzzing safe flag is considered a bug and must be resolved. Very easy, makes all of our lives a lot easier. So in the end, you actually want the requirements versus goals to look like this. You want fuzzing to be a complete part of the developer's goals, but especially in the beginning, you will likely not achieve 100% in that. And there is one situation in particular that I want to highlight because it's a very common thing to occur when deploying fuzzing, and that is fuzz blockers. So fuzz blockers, that's a term used more frequently by now. It means you have a bug that is disruptive for fuzzing operations. That can be because it's maybe highly frequent or it's very resource intensive, and at the same time it's hard to avoid. So you cannot easily work around it and it's blocking you. So that means, of course, it's very high priority to you, but unfortunately, usually these fuzz blockers are low priority for developers initially. There's, of course, exceptions, like you can find a fuzz blocker that is also a security issue, then it might not be low priority for the developer. But usually these bugs are very easy to trigger corner cases that have, at least from the developer's perspective, no real impact on the usability of the product. That causes a high differential in priority. And there is, of course, different ways to resolve this. Later on, when developers are on board with fuzzing, they will consider fuzz blockers also a high priority, and they should. But initially, when you deploy fuzzing, you usually find 1 or 2 fuzz blockers before finding any other bugs or any valid bugs in particular. And that can be a problem because, yeah, we humans, we like to judge others on first impression. Even if we try hard not to, we do. And if the first thing as a developer you see from fuzzing is some useless fuzz blockers, that's going to shape the relationship right from the beginning. So here I actually recommend doing something that might seem controversial to some people. It's not a universal recipe, but it works in many cases, and that is try writing a fix yourself, at least temporarily. And there are a few advantages of actually doing that. So the first advantage about writing a fix is, of course, you learn something about the code you're working with. And that can only be beneficial if you want to do continuous fuzzing on that particular code base. The second thing is you also learn something about development. You learn, for example, what do I need in order to debug this? Do the debugger tools, for example, work with my fuzzing builds, my fuzzing setup? And if they don't, that's a hint for you to actually improve that situation because you wanted to make it very easy for the developer to solve your bugs. Also, if you are successful, you can progress a lot faster. You can just do a local fix and then move on with your experimental fuzzing until you maybe find a real legit bug that is valuable to the developer. And then you can give this bug to the developer and provide your patch for your fuzz blockers in addition. And you can just go and say, like, yeah, I found this issue. Can you look at that? And by the way, I tried to solve some NIT issues here. Can you also look over these patches? And that will make developers usually really happy. They will appreciate the effort very much, even if your fuzz blocker patch is not perfect or it has some issues. They will very much appreciate the effort that you have put into it and not bother them for every single little NIT. So yeah, that's why I recommend you should always try to fix at least one fuzz blocker bug yourself. And usually these bugs are also very simple. Like we're talking about bugs where there's a null check missing and maybe 1 or 2 lines will actually fix the problem already. Another question that I often get asked is like, when should we start doing fuzzing? And so here I have the life cycle of features in Firefox. On the left side, we have experimental features, and then we have nightly beta and the release version of Firefox. And of course, you could now say, well, let's do fuzzing here. I would not recommend doing that. Like, I know this has been done in the industry for some time, that people would use fuzzing as a sort of a gate at release time to do some final testing. I would not recommend doing that for many reasons. There's technical reasons, there's monetary time reasons. It's usually a lot more expensive to fix bugs at that stage, but there's also psychological reasons why you should not do that. Like imagine you're a developer, you spend weeks, months, maybe years getting this release out of the door, depending on your release cycle. And then a security team comes across the corner and tells you, well, we have this nice new technique for automatically finding bugs, which we never used before on the product, but now we're going to use that. And oh, by the way, we found 20 bugs. Can you please fix these now? Because we need to put out the release. Yeah. Developers are really going to like that. So just don't do that. Instead, you should go for the version that is the earliest version that has well-defined behavior. In our case, that is the nightly version. Well-defined behavior here means we know what to expect from that nightly version. In particular, we know if that version crashes or asserts, that's a bug. Of course, nightly is not crash-free, but at least you can be sure that if you find a crash in that version, it's going to be considered a bug by the developers, which makes it a perfect target for fuzzing. This is right after CI/CD. You could actually also move the fuzzing in CI/CD after the regular tests have passed. That would be equivalent. So I recommend having it as close to that as possible. However, sometimes it can also be helpful to fuzz experimental features. But here's a little word of warning. Never turn on any kind of switches for experimental features and do fuzzing on that without consulting with the developers if that's actually a good idea. because usually developers implement experimental features behind some switches, and they are well aware that it's not finished, that there are still bugs present. And by turning those features on and finding issues, you might just find issues that the developers are already aware of. Now you're filing these, developers have to look at it, and you're wasting their time, and that's not going to be very beneficial for your relationship. So the answer to the question when to fuzz is hence, in my opinion, as early as possible, with that star about experimental features, only when you consulted with developers and they actually feel ready for that. So another thing to do is simple steps to reproduce. Make sure that all of your bugs are as simple to reproduce as possible. I know usually fuzzing requires more complex setups. You might have specific fuzzing builds, configurations, and things like that. Try to keep it as simple as possible. Provide all of the steps needed for the developer to reproduce something. Here's an example from Mozilla, where I provide some steps to reproduce. Like, of course, there's a test case attached, but then there's also a script that allows people to download our fuzzing builds together with the necessary tests that contain the fuzzing targets. And usually if you do this manually, you need to unpack, you need to symlink stuff around. That's really complicated, and the script just all does it for you. And then there's one command line that you can just copy and paste and will just reproduce the issue. If developers need to spend a lot of time or they need to do a lot of digging in documentation to reproduce your issues, that's also not going to help your relationship, and they will not be looking forward to fixing fuzz bugs. Another thing that I think is really important for many reasons is measuring code coverage. Of course, there's a lot of technical reasons why you should measure code coverage, but you shouldn't just do that for yourself. You should share your code coverage measurements. That means share them with the developers and whoever else is interested. Of course, there's also technical reasons why you should share it with developers, because developers can point out to you why certain areas, for example, are not being reached. We've already heard about this in Marcel's talk, the human component here, working with developers to actually unblock the fuzzer and get to certain areas later on. That's a really important thing. However, there's more reasons for that. In my opinion, code coverage is a really nice way to visualize your work to the developer. Otherwise, the only thing the developer sees from you is bugs. And seeing this code coverage data, seeing the fuzzer at work on their code can be very helpful to make them understand what you're doing. And that's beneficial for your relationship, of course, as well. And finally, educate. Like, we need to educate developers how fuzzing works, how to develop code for fuzzing, what are the technical things behind each fuzzing technique. Especially, I recommend educating about the requirements. Do not just go ahead and be like, yeah, you need to do this and this and that in order to have your fuzzing up and running. Educate the developers on why you have certain requirements, how these tools work exactly, because some developers are interested and are more likely to follow you when you explain why certain things have to be this way. Yes, and with that, I would like to conclude that fuzzing is teamwork. It's not just teamwork, it's actually a multi-team effort. Fuzzing needs very close collaboration between the fuzzing team and the individual developer teams. And maintaining that relationship, in my opinion, is most crucial to having effective fuzzing operations running in your company. So thank you very much. And I'll be happy to take any questions that you might have now.
So one question is, if you are able to share some techniques you use to increase your code coverage with fuzzing.
So yes, so what we do usually is we do regular code coverage runs. So we use gcuf instrumented builds, and then we have an open source solution to visualize that code coverage. It's part of Fuzz Manager. It's called Cuf Manager, and we look at that coverage together with the developers usually, sometimes we can identify problems with the fuzzer already when looking at this alone, and then we make fixes to fuzzers to improve the problem. But sometimes we just have to look at the code coverage with developers. Developers can tell us, is this likely dead code? Is it a configuration issue? Are we even able to reach this code in this particular configuration on this level? For example, not all of the JavaScript engine code is reachable from the JavaScript shell, and it's really hard for us to tell. So that's why we need this domain knowledge from developers. So just looking at the code coverage, and then depending on your fuzzing technique, you might want to come up with some samples that reach this particular part of the code base and maybe inject that into the fuzzing. That can help to improve the coverage for sure.
Cool, thank you. And then there's another one. Do you think it is beneficial to be able to fuzz the final version of the product too?
I think it does. Of course, it doesn't hurt, but I would never recommend doing that. Like in order to keep that version fuzzable, you need to spend energy. And I think that energy is rather well spent in some other places. So I would not make that a priority at all.
Okay, and then a question concerning the cultural aspect again. How challenging was it to bring up fuzzing culture in your team?
So that's actually a pretty good question. That differs from team to team. So some teams were already initially very receptive about fuzzing, and other teams were more skeptical about fuzzing. In the end, Mozilla has a lot of very professional developers. We are all professional developers, in my opinion, and people were usually all very open to it. Still, you could see that there were some differences in how people reacted. I believe this has to do with different aspects, also with the workload, of course. If people are under high stress and have high workload, they are less receptive to fuzzing, and this is something that management needs to help with. This is not something that we can solve as the fuzzing team. Overall, at Mozilla, I believe it was quite easy to actually get fuzzing accepted compared to what I've seen at some other companies or what I've seen in open source. And I'm very grateful for that. I'm very grateful that we have so many developers that support our work.
Cool. Well, there are so many questions, so I think we we'll answer two more questions, and one of them is: are you planning to release some version of Spider Money already compiled with Azan?
Oh, okay. So this is talking about our JavaScript engine, SpiderMonkey, that is compiled with Address Sanitizer. Actually, we do have this already. Like there are already builds of SpiderMonkey with Address Sanitizer available in our CI, and I believe our fuzzing documentation, which is open source as well, in Firefox source docs, describes how to download builds of the JavaScript shell with Address Sanitizer and also builds of Firefox with Address Sanitizer using a tool called FuzzFetch that one of my colleagues has written. It's a very nice tool to get fuzzing builds from our CI directly and make it really easy for you to have the right build that you want to fuzz. And yeah, we also have this Q&A at the end, I believe, at 6:30, and we can answer many of the remaining questions later on as well, if they are interesting in general for fuzzing, I believe.
All right. Yeah, so I would recommend just one more question. The last question is: are JUnit tests not needed when using fuzzing? Oh,
I think that would be an overstatement. I believe we need tests and we need fuzzing in conjunction. So you cannot replace JUnit tests or any other kind of CI tests with fuzzing. I believe fuzzing is an addition to what you have in CI. I believe tests are really important for fuzzing as well, because some fuzzing techniques actually make use of tests. For example, there's a lot of mutation style tests. We have some JavaScript fuzzers, for example, that take existing regression tests from our CI test suite and use that as an input for fuzzing. So I would never recommend ditching tests in favor of fuzzing. You should always have both. And they also reach different parts of the code base. Like tests are usually written with a very specific intent, and they encode a lot of logic that some of the fuzzers might not have. So yeah, they are supposed to be used in conjunction, in my opinion.
Okay. Thank you, Christian, for this interesting talk, and all the questions just show how interesting it was for the participants as well. And so now we're heading to our last talk before our lunch break. Thank you a lot.
Thank you.
Thanks.